Guys, this is the very last lesson of 2018 for geometry, and we are looking at the Hinge theorem. And yesterday we talked a little bit about the scissors that have the same length, but the angles were open to different widths. And what we learned that the greater the included angle, the longer the opposite side. So in the drawings that we have here, if we are looking at the measure of angle A, and it is greater than the measure of angle X, then what we will know is that segment BC is greater than segment YZ. Okay. Then we have the converse of that, which just means in the opposite direction. That if we have two sides of one triangle that are congruent to two sides of the other, and the third sides are not congruent, then the larger side, the larger included angle, is opposite the longer third side. So let's put that into practice a little bit. Which of the following statements must be true on number 1? We're looking at these two, and I don't know if you can read it very well, but this angle right here says 70 degrees. We know that angle A is 90 degrees because it's giving us the right angle symbol. So which of the following must be true? Is AS less than YU? Well, they don't even correlate together. So what about SK to YU? Again, no correlation. With C, we have SK, and we are saying that that is greater than YU. Yes, those are across the angles. Okay, so that is a true statement that angle C is, the angle SK is larger than YU, so your answer is C. Okay, in the diagram below, you can see that a lot better here than you can see on your paper. We have the diagram showing the position of the swings at two different times. We have angle 1, we have angle 2. Okay. Is the rider farther from point A at time 1 or time 2? Explain how the Hinge theorem justifies your answer. Well, looking at these two, the rider is farther from point A at time 2. Okay, so AB and BC, sorry about the doors, stay the same. And my email. But the angle at time 2 is greater than the angle at time 1. So AC is longer or further away at time 2 than time 1. That's a nice little problem there. All right, let's take a look at number 3. Okay, and you should be able to see those pretty well on this video. All right, so we're looking at PT versus QR. Okay, so PT is opposite the 90-degree angle. QR is opposite the 92-degree angle. So that means that QR, since it's opposite the larger angle, is going to be the larger side. For B, the measure of QTR All right, the measure of QTR is right here at 92 degrees. The measure of RTS, okay, RTS would be right here. All right, you can visually look at that by doing the converse. Again, ignore my email. If you do the converse of the Hinge theorem, you can see that QR is longer than RS. Okay, so that means that the angle that's across from QR is going to be larger than the angle that's across from segment RS. Okay, we also look at PT and RS. So PT and RS, let's change colors on that one. Okay, so we have PT, RS. Okay, we can tell visually by looking at them that PT is greater than RS. Okay, the other thing that we know is that PT is across from the 90-degree angle. RS is across from the smaller angle over here, the acute angle. What is the range of possible values for x? So this is how we're going to do these. So this is probably the hardest part of this whole section. Okay, so I am looking at these two angles, this 60-degree angle right here, and then this angle that is 5x minus 20 right here. Okay, I know that by looking at RS, which is 15, that angle, or that side RS is greater than side TS, because TS is 10. All right, to find the upper limit of what x may be, I'm going to look at the measure of RUS. And I know that the measure of RUS is going to be larger than the measure of angle TUS. I know that the measure of RUS is equal to 60 degrees, but that is going to be larger than the measure of angle TUS, which is 5x minus 20. Okay, so I'm going to solve, and I will get that x has to be less than 16. That's going to be my upper limit. My lower limit, I know that the measure of angle TUS, the smaller angle, is greater than 0. Okay, I know that the lower limit cannot be 0, it has to be greater than 0. All right, so the measure of TUS is 5x minus 20, and again, that has to be greater than 0. When I solve for that, I get x is greater than 4. Okay, so how we write that is we have 4 is less than x, which is less than 16. And you should remember that from your Algebra 1 class. All right. Let's do that again. So your range is between, on that one, 4 and 16. Can't be equal to 16, can't be equal to 4. Has to be in between there. All right, for number 5, what's the possible, or what is the range of possible values for x in the figure below? All right, so we have our upper limit. Okay, which of these triangles is larger? Well, this one's 9, this one's 7. So the measure of angle LKM is going to be less than the measure of angle ONP. Okay, the measure of angle LPM is 3x plus 18, which is less than the measure of angle ONP, which is 90 degrees. Okay, subtract 18 on each side. And I know that x has to be less than 24. 24 is our upper limit. Or our lower limit. Okay, my smaller angle is triangle LKM, So I'm going to take the measure of angle LKM, and I know that that has to be greater than 0. Okay. So I will plug in 3x plus 18 again, which is going to be greater than 0. Solve for x, and x is going to be greater than a negative 6. So my range of values for x, again, that's not my range of values for the angle, but my values for x is between negative 6 and 24. That's my range. Okay. Again, remember that on Thursday when we come back, I will be happy to go over a couple of these with you. Again, please excuse the text messages that were coming in. Please excuse the lady next door that was cleaning the floors. Hopefully you were able to hear all of that, and I will see you guys on Thursday. Please remember to have that notebook in order and ready to grade. Have a great night.